you know, I've drawn them like this so you can get an idea that we know that, in a capacitive circuit, we have voltage that is, lagging, current is ahead. So, and that's, we know that because of Eli the Iceman, right? Where in a capacitive circuit, the current is ahead of the voltage. Okay, so where do we start here? We know 120 volts RMS. We know resistance of 100 ohms. We know our capacitance of 10 microfarad. So the first thing I would do here is, because we know our capacitance, I can find my XC. Once I find my XC, then I can find my impedance here. So that's where we're going to start. So first one, so we'll go XC is 1 over 2 pi FC. Don't have to label C because there's only one. 2 times pi times frequency of 60 hertz times 10 to the exponent negative 6 is 265.26. Okay, so I'll put that over here. Now we can find Z. Okay, so what did anybody get for Z? Square root of 100 squared plus 265.26 squared. 283.48. Thank you, Aiden. 283.48 ohms. Let's see. All right. So now that we have Z, we can also find our power factor and our phase angle. We can find our power factor and our phase angle here. So I'll put it over here. I could say my power factor is going to be equal to R over Z. 100 divided by 283.48. And I get a power factor, 100 divided by 283.48. I get a power factor of 0.3527 times 100. So 35.27. %. And out of this, we can also find our angle theta, which is going to be the arc cos of 0.3527. And for my arc cos 0.3527, I get 69.34. So as my phase angle, 69.34 degrees. So out of all that, we're able to get our power factor. Out of finding our capacitive reactance, we're able to find our total impedance. Now that we have our total impedance, we're able to find our power factor and our phase angle. Now we have these values here. Let's find our currents. Once we find our currents, then we can start working our way down through here. So my current IT would equal my ET over my impedance. 120 volts divided by 283.4. 0.48 to be accurate. Uh, 120 divided by 283.48. I get a 0.4233. It's 0.4233, 423.3 milliamps. So now we can start working on our voltages. And we know that our ERMS voltage is 120 volts. We know that as our vector here, that's our hypotenuse. So, that's going to be this value here. So there's a couple ways that we can find it. I mean, the easiest way, you can use Pythagorean, or you can use, you have to get one other value. You can actually use because you have your angle, you can actually use your angle. And I think my next one, one of them, there's a couple of them I actually will make you do that, where you got to use a phase angle in order to find out what your values are. So hopefully we'll get to those today.